In this video, we are going to start with the basic terminologies what we use in LPP. Okay, now what we mean by terminologies, whenever we talk about terminologies, there are certain words which you need to know the definition of it, like what it means and how are we going to use it in what context. Okay, now whenever we talk about different terminologies in this chapter, that is LPP, the first very important word is, see, whenever we talk about anything, any LPP problem, let's look at it in this way. What is the need of LPP? Like, why are we going to do it? Now, let me give you a scenario. Okay. Now, let's assume that we have a person and that person is the owner of a, let's say, a godown. So, what we have is, imagine you have a godown, a big godown, and this godown can fit around 50,000 products inside the godown. It's a big godown. But he is, whenever he's doing a business, he wants to maximize his profit, isn't it? So because he owns a godown, but for every article he's going to store in that particular godown, he has to pay tax to the government, right? And every product he sells, he's going to sell it with some particular, sell in the sense he's going to transfer it, correct? So he's going to get some money because he stored it and he's going to go it, isn't it? He's going to go and give it to someone. Now let's say he has TV and computer. Let's say it's an electronic go down. Okay, now let's say he has TVs. Only will take only two. Okay, let's say he has TV and then he has laptops. He has only two products in his go down, and totally we have 50,000 total of 50,000 TVs and laptops in total. Now, what he has is TV, let's say a normal TV. Okay, so now the normal TV on an average, it is costing a little more than the laptop. Okay, so let's say uh, a TV costs around, on an average, the TV is gonna cost around 50,000. This is the cost. All right, and laptop on an average is, let's say, about 30,000. All right, so this is for the TV and this is for the laptop. But there is a catch. He cannot store the entire thing with TV because totally 50,000 items can be stored, but TV occupies more volume compared to laptop. Laptop has smaller volume, isn't it? So if he is stacking up the entire godown only by TV, then what's gonna happen is, let's say he can fit in maybe around, say, 4,000 TVs or maybe 5,000 TVs, something like this. Okay, let's say 5,000 TVs he can fill in. 5,000 TVs. Whereas laptops, he can fit around 9,000 laptops in that same volume. Okay, now 9,000 is here and 5,000 is here. Now, guys, if you look at this, obviously you might think that, what if I store everything by laptop? But there is a catch. The catch is, see, this is how many TVs and how many laptops he can fill in that particular volume. But for storing TV, he has to pay tax. So what do we have here? One is that the cost of the article when he's selling, right? Second, the cost of the laptop when he's selling, that we know. And how many TVs and how many laptops he can store within that godown. This also we know. We do also have to know that what is the tax he has to pay if he stores a TV. Okay. Suppose if he is storing the TV for a day, then he has to give a tax of 2 rupees for the government. If he stores for one day, for one TV, he has to pay 2 rupees. Okay. And let's say 2 rupees, very nominal, 2 rupees. And for laptop, every laptop he stores, he has to pay, let's say, 0.7 rupee. That's 70 paise as the tax. Okay. Now my question is, See, we know the selling price, what he's gonna sell it, and we know what is the tax, correct? And we also know how much of those articles he can store within the godown. Now, how is he going to maximize his profit? He can't say that I'm going to keep all the TVs itself because tax is going to be more. And he can't say that I'm going to keep only the laptops because TV is going to give us more profit margin. So he has to keep the this one TVs also, and he also has to keep laptop also, isn't it? But he has to keep it in a particular number in such a way that the profit is maximum, isn't it? So these are the type of problems what you have in LPP. You can think of this in like a theoretical example or even a practical example. Whenever we talk about the theoretical part, you have a mathematical model for this one. Understood? So these are the problems what we have in LPP. So now you understand the practical application of LPP. So now that we have here, guys, I'm just giving you an example, right? Cost is this, tax is this, and he has to maximize his profit, all these things. So how are we going to represent this mathematically? This is where the terminologies are very, very important. Because if you know the terminologies, you can clearly understand like, oh, this is what I'm talking about. Or this is what the question is saying. Or this is what this person is telling. Correct? So those terminologies are very important. Let's start discussing the terminologies now. The first terminology what we are going to use here, or you need to understand, is a constraint. Constraint. Now, what we mean by the constraint, very, very important. See, every LPP or a linear programming problem, we need to define it like a mathematical model, correct? See, when we're defining it like a mathematical model, we need to have a variable, right? So, those are what we call as decision variables. Decision variables. Generally, we represent them as X and Y. Sometimes you might have Z also. I mean, but generally Z is used for a particular other part. You'll understand that. See, when we talk about decision variables X and Y, a constraint is like a condition, right? Now, these decision variables has to have a condition. That condition of the decision variables, they are what we call as constraints. Okay, they are constraints. Like for example, if I say that X is the number of TV in the example what we took, suppose if this is TV and say this is laptop, a very, very important part what you need to understand is that X should be greater than 0. Y should be greater than 0, correct? See, you cannot have negative number of TVs. You cannot have negative number of laptops. So there is a condition, a constraint for the decision variable. So constraint is what again? Constraint is the restriction what we have for the decision variables. They are called as constraints. Fair enough? So this is the first terminology what you guys need to know. Okay. The second one what you guys are going to understand is what exactly we mean by objective function. Objective function. See, objective function in the sense that if you again take that example of the go down and maximizing and everything, see here there is one particular problem what you're trying to maximize here, correct? What is that problem? Problem is I need to maximize my profit, right? So that particular condition or that particular issue what we have, so that is basically an objective function. Okay, so we need to look at objective function. What is your objective? What is your motive for solving that problem? Your objective is to get the final answer, correct? That means my objective is to maximize the profit. Make sense? So the function, what you're trying to understand and what you're trying to get the final part of it. That is basically an objective function. Understood? Now, most of the times, objective function is denoted by z. All right. Z will be in terms of the decision variables, maybe something like, say, 50x, 50x plus 30y, something like this. Fine. So, this is what we call as the objective function. The next parameter, what we have is what we mean by maximize or minimize. Maximize or minimize. See, maximizing a problem, maximizing a profit, or minimize the cost, minimize the loss. Correct? So, maximize and minimize meaning either the optimal, sorry, in the sense the objective function has to have a very big value. We are trying to figure out the what it is. Or the objective function should have a very less value, the least value. So those are basically the criteria what we put for the objective function. That means, see, a constraint is for the variable, correct? So once you have the constraint, you have the objective function, and then we have the maximizing and minimizing part, right? So what do we do with that objective function? That is given by this particular parameter, that is maximize or minimize. Clear? So this is maximizing or minimizing. All right. So we can say condition of z only, all right. All right. Then the next one what we have is optimization problem. See, optimization problem is you have that objective function, correct? So objective function, we are trying to write that as a mathematical form, right? Z is equal to something, something, right? So that function, what you have, that is a mathematical problem. That is what we call as optimization problem. So once you have the optimization problem, we are going to get a region for it, or you're going to get a feasible solution for it. Understood? So this is what we are going to understand the next part, that is feasible region. Feasible region. See, feasible region meaning what? This is that region when you graphically do it or when you graphically plot it, this particular region is going to give us the required answers. Remember, not answer, answers, because it's a region. In a graph, it's the area under those points. Understood? So this is the region which is most suited for the given optimization problem. Like for example, say I'm trying to maximize the profit and I'm getting answers in negative. It's not even feasible, isn't it? So the feasible region is where it gives a range of values for the optimization problem. Clear? So there's the range of values, or you can say the region of values. Correct? It's the first part. It's a region. Clear? Now, once we have the feasible region, because I was talking just now, I was talking about maximizing or say minimizing or whatever it is. Correct? So basically, they are what we call as optimal solution, which is the next part. Say optimal solution. The meaning of optimal solution, I think you guys can guess right now, isn't it? It's quite simple. Now it is that value, when you put it in the objective function, it's going to satisfy that one. Like say for example, I'm saying that I need to minimize my cost in transporting goods between two cities. See, minimizing is my objective, isn't it? So you're going to take a particular value. Let's say in this case, say you're going to get some least value, assume. Okay. If you're getting a least value and that is the lowest, the solution what we have, that is basically an optimal solution. That means the best solution what we have for the particular function, or you can also call it as an objective function. Clear? So this is what we call as an optimal solution. So this is also more like a best value. It's the best value possible. Fine. Now once you have the optimal solution, remember we are doing LPP on a graph. So when we draw the graph, see here something like this. Something like this. Now what we do, let's take that this is the region what we are taking. See in here, what you need to understand is that there is 1, there is 2 and there is 3. Right? So there are 4 points. Now of all the 4 points, what are they doing? These 4 points, they're closing the curve, correct? They're closing the curve. So this one is what we call as bounded region. All right, this is what we call as the bounded region. Now, once we have the bounded region, there is one more type that we call it as unbounded region. Like in this one only. See here, it doesn't end anywhere, it just keeps on going, correct? So this is what we call as an unbounded region. Unbounded region. Understood? So these are certain terminologies what we use in LPP, because if you know these basics, you can directly start with the problem, you can do a lot of things. Fine? So go through the video one more time so that you understand the terminologies. Alright? Now in the next video, we are going to start with problem solving or LPP.